Fine. So first we are going to discuss about the comparison between human learning and machine learning, or analogy between the human learning and we will discuss about the various components in the machine learning, and later we are going to discuss about the what are the different types of the real-time problems that can be addressed or that can be solved by using the machine learning algorithms, and what are the different types of machine learning models, and what is the complete structure of the machine learning project. So these are the things we are going to discuss in the first half of today's workshop. Okay. So first, I'm trying to see my approach will be, hope that I'm delivering a session to a layman who don't know anything about the machine learning or AI. So the participants who are familiar with the basics of the machine learning, sorry for them, just wait for a few hours. So to move into the different types of machine learning models, mathematics. So first I will start with the comparison between the human learning and machine learning. I'm trying to compare actually, because machine learning is a part of artificial intelligence. Why it is called as artificial intelligence? So if you want to know the why it is called as artificial intelligence, so you must know about what mean by the natural intelligence or natural learning, right? Machine learning is a part of AI, artificial intelligence. Natural learning, how we learn ourselves, that is a part of natural intelligence. So I'm trying to compare that natural learning or human learning or natural intelligence with the artificial intelligence or the machine learning, like that. I'm trying to build some relation, some analogy, so that you can understand well. Okay. So keep machine learning concept aside. Just we will focus on human learning. Later we will compare. So let's assume, okay, in my perspective, I will explain. I have a girl child. I want to make her learn. I have a girl child and I want to make her learn. So that means here, who is learning? My child. My child is learning, and I want to make my child learn to survive herself in future. So I want to learn some concepts, some knowledge based on the requirement of the society, right? So if I want to make my child learn, that means here the part is my child, my kid is going to learn some concept, some knowledge based on the current scenario, current society needs, right? So here who is learning? So that if you want to learn something, some human being is required. That may be a girl child, that may be a boy child, some human being is required. So now I have a child, I want to make her learn some concepts. That is called the human learning, right? Fine. Now I have a child, I want to make her to learn something. I want to make her to learn something. Then what we will do? What we will do? We will send our child to some school. That may be pre-KG, what it's called, some school where I'm trying to send my child, right? So if we send our child to the school, so how she starts learning, how human learning starts, how my kid starts learning. Okay, if my child wants to learn something in the school, then the school people will give some data, some information, some material based on the what she want to learn. Suppose in my childhood days, when my parents send me to a school, at that time, my teachers give the information, give the materials, gave the data like like that. Just they gave one slate to me. On that slate with the chalk, they write and That is called data. That is called information. Those things I want to learn. Hope you understand. So he gave that information. So then as a child, what I did at that time, I will write multiple times that Telugu letters, whatever it may be. But nowadays what happened, if we send our child to the school, then the teachers will give some other information, some other data, like maybe nowadays they are directly started with the English alphabets, right? So what I want to tell from all this discussion is, if I want to make my child to learn, then the school will give some information, the school will give some data, school will give some materials to learn. Based on what she want to learn, that type of materials they will provide, that type of data they will give, that type of information they will provide. Suppose if I want to make my child to learn English, they will give the English alphabets. Or if I want to make my child to learn Telugu letter, they will give the Telugu letter information. If my child want to learn some number, they will give the numbers. If my child wants to learn, if I want to make my child to learn some Hindi letter, they will give the Hindi letters, right? So based on what my child want to learn, on which topic, in which area, which knowledge I want to make my child to learn, based on that, they will give the data or the information or the materials, whatever it may be. I hope you understand. That means to learn something, if my child is available, that is not sufficient to make her to learn. To learn something, if my child is available, that's only my child is not sufficient to make her to learn something. Apart from that, we have to give some data. We have to give some data. I hope you understand what I want to say. We have to give some data, some materials like ABCD, or you have to give some numbers, or you have to give the Telugu letters, whatever it may be, we have to give the information what she want to make to learn. Okay. So now if the human want to learn something, what are the required information? One is that child is required. Without child, to whom the school will learn, make them learn, to whom they will teach, right? So child is required. If only child is available, that is sufficient? No, right? So we have to give some materials to the child to make her to learn something based on the topic or the content what she want to learn, what school want to make her to learn, right? If materials are available, if child is available, that is sufficient. If that is sufficient, then I don't want to send my child to school. I will bring the materials and I will paste it on a table, on my wall, and she will, by seeing that materials, she will learn everything. By seeing that materials, she will learn everything. I hope you understand. Okay, so then what you have to do? And one more thing, suppose in Warangal, if you take in Warangal, we have the more number of schools also, right? Every school they will make the child to learn about the ABCD or 1, 2, 3, whatever it may be. Then why I will send my child to particular school? What is the difference from the one school to the another school? Hope you understand. Suppose if you want to make your child to learn something, so you have to give some materials. If the material is available, child is available, do you think that is sufficient? No, right? So you need something extra, right? If that is the case, you can directly, blindly, you can send your child to some schools directly. But we are not doing like that, right? We are searching for the multiple schools, and finally we are identifying our particular school, and we are sending our child to that particular school only. Why? What is the difference from the one school to the another school? So that is approach. Approach means what strategy they will follow, what approach the school will follow to make our children learn based on the content available. So if my child or anyone's child, when she is joined in the school, definitely they will start to make them to learn some English alphabets, let us assume. Every school will do same thing. Then, but different schools will follow the different strategies, different schools will follow the different approaches. I hope you understand. So there's a different strategy, different approach they will follow to make my child learn based on the information or data available in the material. different strategy, different approach, right? See, some schools, like olden days, some schools may still follow, they will give the slate and they will write A, B, and the children will write multiple times A, B, A, B, A, B, A, B, multiple times. That is also one of the strategy. Or some people's, what they will do, maybe they will give some notebooks, and on that notebooks they will ask the children to write multiple times. Or some schools make the children to learn based on the some activity, some interaction. Or some schools may follow one child get up and he or she will tell A, B, C like that, and remaining all the people will follow. So what is the change here? So one school follow one strategy, another school follow another strategy. This is the continuous process. Strategy is different. Hope you understand, right? So in this complete discussion, around 15 minutes of complete discussion, you have to concentrate on the three things. One is the person who want to make them learn. Person who want to make them learn, or the person who want to make to learn something. And the second point is content. So based on what content, based on what data, based on what information you want to make your children to learn something. That is the second point. Third point is called as the approach. Approach means you have a children, you have the material, but how you make the children learn based on the content available in the material. What strategy you will follow, what approach you will follow. So these are the three important things in the human learning. Okay, so in the human learning, the child must be there to learn. If no one is there, to whom we will teach? If there is no one is there, who will learn then? Right? So the childs or people or the students are required in the human learning. Second thing is, if the child is there, that is sufficient? No. So if the child is there and if you want to make her or him to learn something, what you have to do? So you have to give some materials based on what concepts you want to make them to learn. So second thing is data or material or information is required. If the child is available, if the data is available, is it sufficient? No, right? So we have to give some strategy. We have to follow some strategy. We have to give some approach. That approach or the strategy which we will use make the children to learn based on the content available. So these three parts are very interlinked. So one is the child, another is the material or the data or the information, and what are the activities or what are the approach we are going to follow. So these are the very three important things in the human learning, right? So I think I no need of a better explanation for these things. We come across everything, and most of the participants are the students and the faculty. Everyone know how the learning process are going on in the schools and the colleges, right? If one student is joined in the university for engineering program, if one student is joined, so the child is available, the student is available. If the student is available, that is sufficient to make him to learn all the engineering concepts? No. We require some data. We purchase some books, we will provide some materials, the data is required. If these two are available, that is sufficient. If that is sufficient, no one come to the college directly. So there is some strategy, some approach we have to follow to make them, the students will learn based on the available data. So the three importance are available. Now, these all are about the human learning. It is a part of natural intelligence. Now I am trying to compare this one with the machine learning. I am trying to compare this one with the machine learning or the artificial intelligence part. Is a part of the machine learning is a part of the AI or artificial intelligence. So in the artificial intelligence also, we have a machine. We have a machine. Machine learning. We want to make the machine to learn something. We want to make the machine to learn something on a specific problem. It may be a COVID prediction, it may be a load forecasting, it may be a energy price forecasting, it may be a wind energy forecasting. So it may be a sentiment analysis, whatever it may be, a specific problem. So for a specific problem, I want to work a machine I want to make my machine to respond accordingly. I want to make my machine to learn something for a particular problem, right? So your machine, you want to make your machine to learn something. You want to make your machine to learn something. So then what is required? Then what is required here? So what is required here? So you have the machine learning model, or if you have the deep learning model, suppose you want to make your machine learning model learn based on for a specific problem like a COVID prediction, let us assume. For a COVID prediction, you want to build some application, and that application will tell whether the person has a COVID or not. I think it's clear, right? So you have the machine learning model. We have the different machine learning models. You want to make one machine learning model to learn, and it will give some decisions. So for a specific problem, let's assume you want to build one machine learning model. You want to train one machine learning model for a COVID prediction. So COVID prediction means if you feed some data to your machine learning model able to tell whether the person has a COVID or not, right? So generally see, if I learn ABCD, what I will do, if I see something A letter on the wall, I can easily recognize this is the A. Like that, I want to make a machine learning model to learn on the various patterns of the COVID. Later, if it found any pattern related to the COVID, it will tell this person has a COVID. If it is able to see any pattern related to non-COVID patient, then it will tell that no COVID, right? So let us assume, just I'm taking one example, one problem. Just I want to make my machine learning model to tell the person has a COVID or not. So you can take one machine learning model and you want to make them to learn. If you want to make the machine learning model to learn. Now, just imagine if your child is available to learn something, you are feeding some data, you are feeding some material. Similarly, if you have a machine learning model, you want to make that machine learning model to learn a specific problem, you have to provide the material, nothing but data. You have to provide the data. You must have a data. Why we require data? Because if you have a data, then only your machine learning model will learn. That's right. If you have a child, your child will not learn anything until you give some material. Similarly, if the machine learning model is available, your machine learning model will not learn anything until you give some data related to your problem. Is it clear, right? So, if the machine learning model is available, then you have to give some data to that machine learning model to learn something. Okay? So, you must have a data, you must collect a data, you must process a data. So, let us assume I want to make my machine learning model to learn based on the previous COVID patient data, and based on that machine learning model, I want to build an application, and that application will tell whether the particular person has a COVID or not. So to get that experience, that knowledge by my machine learning model, first you have to make your machine learning model to train something. You have to make your machine learning model train to something. So to train the model, to make your model to learn, you require the data. How you will get the data? So you have past or historical patient data from the hospitals. You can hospitals. In the hospitals, they have all the data informations of both patients, COVID patients and non-COVID patients. Every data is available. You have to collect the data, and using that data, you have to train your machine learning model. You have to make your machine learning model to learn. If the data is available, you can collect the data from the hospital. You have the machine learning model. These two are sufficient? Is the child and the material both are sufficient to make her to learn something? No. What else required? Some strategy. Similarly, in the machine learning also, if you have the machine learning model, if you have the data, these two are sufficient to make your model to learn? No. There is one more thing is required. What we are seeing in the natural intelligence or natural learning or human learning, in addition to the data or material, in addition to the child, you must follow some approach, some policy, some strategy to make the child to learn. Similarly, in the machine learning also, you have the machine learning model, you have the data. In addition to the machine learning model, in addition to the data, you must use one approach, one strategy. So that is the optimizer. So the optimizer is very, very important. That optimizer is very, very important. That optimizer will tell how machine learning model will update the model parameters. That optimizer will tell how your machine learning model will learn based on the available data. So that is a very key part of your machine learning or heart of the machine learning model. So optimizer or optimization technique will help the machine learning model to update its model parameters based on the available data that what we are feeding. Okay. So the optimizer will tell how machine learning model will learn. The optimizer will tell how machine learning model parameters will update based on the data what we are feeding. Okay, so that's why, so these three are the very, very crucial parts in any machine learning. So I want trying to create an analogy. Here my child, I'm trying to compare with the machine learning model. Here my child want to learn, here we want to make the machine learning model to learn something. And if my child wants to learn, we need to provide some data, some materials, right? Similarly, if you want to make your machine learning model to learn something, then you have to feed some data based on your problem that you can, right? So if the data is available and if the machine learning model is available, then these are the sufficient? No. So you have to feed you have to give some optimization algorithm. We must know, we must apply some optimization algorithm. This optimizer or optimization technique or optimization algorithm will help your machine learning model to learn based on the available data. Based on the available data. So I think that you are able to understand the comparison between the human learning and the machine learning. Just only I'm trying to explain. So because we all know about the human learning, and I want to explain the machine learning in perspective of the human learning so that participants are able to understand easily. So simple way, that is so in case of the human learning, so we have the child. So we are feeding the materials to we are giving the materials to the child, and we will follow some strategy. So based on that one, your child will learn something. So similarly, coming to this is about the natural learning or natural intelligence. Whereas in coming to the machine learning, so you have to choose some proper machine learning model based on your problem, and you have to give the data that based on your problem, and you have to choose one optimizer to make your machine learning model to learn. So what this optimizer will tell? So optimizer or optimization technique or optimization algorithm will help the machine learning model to learn based on the available data. Or in other way, our optimizer will help your machine learning model to update its parameters based on the available data. Once the learning was completed, then if you deploy your trained machine learning model in the back end of your any application, if you give the input values, it will give the predicted value. It will give the predicted value. So I am trying to compare the human child can be compared with the machine learning. Your materials, what we are using in the schools or colleges, can be compared with the data. The strategy what colleges or schools are following is compared with the strategy. So these are the things you have to remember, right? Now, so once again, so what are the components of the machine learning based on our complete discussion around, I think I took 30 minutes to explain these things. For 30 minutes, based on our 30-minute discussion, what are the main components or the core components of a machine learning? One is called as machine learning model. One is the machine learning model. And second part is the data. And third one is the optimizer or optimization technique or optimization algorithm. Okay. So we have the different machine learning models are available based on the literature. And you can also build your own machine learning model also. But if you want to develop your own machine learning model, you must be good familiar with your mathematics. Okay. So coming to the data, so you have to give the data. See, when you are working on any machine learning project, my suggestion is you have to spend more amount of time on the data preparation. If your data is good, everything will be going well. If your data is worst data, then how many days you make your machine learning model to train, there is no use. That's why we have to spend a lot of time in the complete project duration on the data collection, data preparation, data pre-processing. We have to concentrate well on it. If you are feeding the wrong data, what your machine will do, what you will give, that will learn accordingly. For example, if a child come to the school, I wrote letter A and I said it is a B, then what he will do? In next time onwards, whenever he saw letter A, every time he called it is a B. Because we are feeding the data in the wrong manner. Here also same way. You have a machine learning model, and if you feed the wrong data, it will predict wrongly. That's why you have to much concentrate on the data preparation. You have to concentrate much on the data preparation. That is very, very important. So you have to spend more amount of time here. See, for example, I'm telling that how we prepare a data, how we form that, how we prepare the data, we will discuss now. See, let's assume, suppose I want to build some COVID diagnosis application. I want to build some application to diagnose the COVID, right? Let's assume, okay. So application is like a software application, it has a front end. Like a software application, it has a front end, right? So let's assume, what are the features you want to consider whether the person has a COVID or not? What are the features you want to consider to identify whether the person has a COVID or not? How you will get that information? That's why whenever you are working on any machine learning related project, if you are working with any machine learning related project, then you must consult with a domain expert. Domain expert. Domain expert means, because as a techie, we can manipulate with the program, we can play with mathematics, but we don't have the much knowledge, much experience on the domain, right? So how we know what are the features, what are the parameters we need to consider for the COVID diagnosis? Who will give the information? So we have to consult doctors, we have to consult hospitals, we have to ask them, sir or madam, I want to build one application which is able to diagnose the COVID. So what are the parameters we can consider for a COVID diagnosis? So you can consult them. For example, let's assume I want to diagnose the COVID based on some parameters like fever. So I have to feed the information about the fever. O2 level, I have to feed the information about the O2 level. And let's assume cold, whether the person has a cold or not, let's assume. And I want to give the information about the patient cough status, whether I have a cough or not. And I want to give the information about the some like a pulse rate, let's assume I have to give the pulse rate information. And in the application bottom, at the bottom of your application, there is a submit button, right? Now I want to build an application like this. So what it will do? So I will give the fever, and I will give the information about the oxygen level. I will give the information about the cold. I will give the information about the cough. I will give the information about the pulse rate. And once I submit it, then it will go to the another page, or the same information will be posted on the same page also, maybe positive or negative. It will give the information like COVID positive or COVID negative. But in between, that means your input page or front end page and your response page, in between we have to deploy your trained machine learning model. You have to deploy your trained machine learning model. So what this machine learning model will do, it will take all the input features, all the information provided from the front end. It will take all this information. Based on the updated model parameters inside your machine learning model, some mathematical operation, it will give the response like a positive or negative, right? So this is your front end, and this is also a front end, because your response also comes in the front end only. So in the back end, you have to deploy your machine learning model. Machine learning model means that was trained machine learning model. That will be a trained machine learning model, right? Hope you understand. You have to apply the trained machine learning model. So when you are making the machine learning model to train, if you want to make your machine learning model to learn something, I said that data is required. So how we prepare the data? So you have to prepare the data based on the input features of the past patients. Now go to the hospital, collect the patient one form and note it down. What is the fever value of that patient? What is the O2 value of that patient? What is the cold of the patient? And what is the cough? And what is the pulse rate? And you have to give the label data also, whether that is a positive patient or negative patient. That also you have to prepare. Similarly, the patient one. Similarly, go to patient 2, go to patient 3, patient 4, and thousands of data you have to collect. For every patient, you have to collect the information about the fever, O2, cold, cough, pulse rate, and you have to label it whether the person has a COVID or not. Lab data, based on the lab data. So like that, you have to prepare the thousands of samples of data. Let's assume I have collected the data from the 1,000 patients, then the data size will be 1,000 cross column 1, 2, 3, 4, 5, 6 columns. Out of 6 columns, 5 columns are the input features, fever, O2, cold, cough, and pulse rate, and last column is your output column. So that data preparation is very, very important. Okay, as you are working on a machine learning model for a COVID diagnosis, you have to collect the data related to the COVID patients only. That's why I'm saying. So on which problem you want to work on, based on that problem, you have to collect the data. So if you want to build an application for the COVID diagnosis, and if you collect the data from other diseases, there is no use, right? Right? If I want to survive my child in Western countries where they are speaking in English, then I have to make my child to learn English alphabets only, not Telugu. Hope you understand. Like that, if you want to build one machine learning model, if you want to build one application for a COVID diagnosis, then you have to give the data related to the COVID, right? Another example I will tell. Let's assume you want to build one machine learning model to estimate the housing price in Warangal. Let's assume for the purpose of Warangal people, you want to build one application which is able to tell the house prices in various locations in Warangal. Let's assume. Then you have to provide the data related to the housing price from the Warangal region only. If you collect the data from the Hyderabad or Bangalore and Chennai somewhere, and you train the model based on that Bangalore data, and if you apply it for the Warangal housing price prediction, is there any use? Right? So on which problem you want to work on, so you have to collect the data accordingly. That is important, right? So if you are not doing like that, then there is no use of your machine learning model, or there is no use of your application. Right? That is very important, right? So that's why I told that you have to concentrate most of the time on the data preparation. You have to think twice, thrice whether the data is properly going or not. So that is the very, very important thing. So hope you understand, right? Up to now. Okay. So that's why. So that data preparation is very, very important. So that is the data. Okay. And machine learning model. So that machine learning model also based on your problem, you have to choose the proper machine learning model. That I will come across in the next slides. So you have to identify proper machine learning model based on your problem. And second one is you have to collect the data based on your problem statement or based on your problem. Next one is you have to choose one optimizer. So you have to give one optimizer. So that optimization algorithm or the optimization technique will tell your machine learning model to learn based on the available data. The optimizer will tell the machine learning model to learn based on the available data during the training process. Okay, so during the training process, your optimization algorithm will tell the machine learning model to update the model parameters or tell the machine learning model to learn based on the available data that we are feeding. So that's why these three are the major components in a machine learning. Okay, so we have the different types of optimizers like stochastic gradient optimizer, we have the ADA grad optimizer, we have the ADAM optimizer, we have the, so different type of optimizers we have. But in this workshop, we are not concentrating on the different type of optimizers. We are concentrating on the different types of machine learning models we are going to concentrate. Okay, and the data also important, and machine learning model also, identifying the, choosing the proper machine learning model also very, very important. So I think you are clear with comparison between the your machine learning and human learning, and you are going to understand the analogy between the machine learning and the human learning, and hope you are able to understand the major components of the machine learning, like machine learning models, data, and optimizer. So I think you are clear with these three things. Fine. Now we will keep that basic aside. Now we will try to work on the different types of real-time problems. We are trying to focus on the different types of real-time problems, or how we classify the different problems available across in real time that can be solved by using the machine learning techniques. So these problems are mainly classified into three categories. One is called as the regression, classification, and clustering. So most of the problems come across real time will be fall in any one of these bucket. It may be a regression problem, it may be a classification problem, or it may be a clustering problem. So that's very important, right? We have to know which type of problem we are working on. So if you are working on some project, and if the expert asks you which type of problem you are working, you must be in a position to tell, yes, this is a regression problem, this is a classification problem, this is a clustering problem. You have to tell. So I come across some people, they completed the complete project, including the application development. But when we ask which type of problem it is, sometimes they may be confused to identify the type of the problem they are worked on. That's why that the basics are very important. So the real-time problems are classified into three categories. So that is called as the regression, classification, and clustering. I'm going to discuss about the one by one. So what is the regression problem? So regression problem means, in a problem, if you want to predict a variable, if you want to estimate, you want to forecast a particular variable, if that variable value is a continuous, then it comes under the regression problem. So regression problem means, if you want to forecast, if you want to estimate, if you want to predict some variable, by nature, if that variable is continuous number, that variable is a continuous number, then it is called as the regression problem. For example, here you can see one example. I have one machine learning model. So this machine learning model will take the three inputs. That means this machine learning model able to predict one variable, the machine learning model able to estimate, able to predict, able to forecast one variable based on the three features. One is called L of t minus 1, L of t minus 2, L of t minus 3. So this L of t minus 1, L of t minus 2, L of t minus 3 are called as the input features. So these three are called as the input features. So input features means, based on these three features, the model is able to predict some other variable. Okay, these three are called the input features. And what about the L of t? So L of t is called as the output variable. That is the variable we are trying to estimate. That is the variable we are trying to predict. See, in other words, here L of t is nothing but the, actually this is the screenshot of one of my paper. So L of t is nothing but the load on a particular electrical substation at time t. L of t is nothing but the L for load on a particular substation at time t. So I want to forecast the load on a particular substation at a time t based on the three input features, three input parameters. Those three input parameters are what will be the load on the same substation 1 hour before, what is the load on the same substation 2 hours before, whatever the load on the same substation 3 hours before. So based on the last 3 hours load data, I want to forecast the load at the next hour. For example, now the time is 2:30. I want to forecast 3 p.m. today. I want to forecast the load at 3 p.m. today. So I want to forecast the load at 3 p.m. today based on the load available at 1 hour before 2 p.m., 2 hours before 1 p.m., 3 hours before 12 p.m. So based on these three data points, I want to predict the load what will be the load in the 3 o'clock today, 3 p.m. today, right? So this is the actual the screenshot. Now tell me, out of these four parameters, we have the independent parameters and dependent parameters. So L of t minus 1, L of t minus 2, L of t minus 3 are called the independent parameters or the input features. Why it is called as independent parameters? Because these three values are not depending upon any other parameter. That's called as it is an independent parameter. Whereas L of t is called as the output parameter or output variable or dependent variable. Why it is called as the dependent variable? Because the value of this variable is depending upon three features, that is L of t minus 1, L of t minus 2 and L of t minus 3. So in the machine learning, the dependent variable or the variable you are going to predict or the variable you are going to estimate, if the variable value is a continuous number, then it is called as the regression problem. That is called as the regression problem. So hope you understand what means by the regression problem. I will give some case studies. Let's assume I got one problem statement. That problem statement is build machine learning based application to forecast the energy price, That is the problem statement that I have. So what I am trying to forecast? I am trying to forecast the energy price, electrical energy price. Now, this type of problem is which example for the regression problem? Why it is the example for the regression problem? Because the dependent variable or the output variable or the variable which you are going to predict that has the any value. Your energy price any value, right? It may be a 5,000 rupee, it may be a 6,000 rupee, it may be a 5,550 rupee, it may be a 10,000 rupee, it may be 18,000 rupee, it may be 8,000 rupee. Any value, right? So that's a continuous number, and it may be a 8,122.5 rupee. Any value that may be, right? So that's why that is the example for the regression problem. For example, if you want to build an application for the temperature forecasting, temperature prediction, if it is a temperature prediction, if it is a temperature forecasting, then tell me that is the example for the regression problem or not? So that is the example for the regression problem. Why it is the example for the regression problem? Because it is a temperature forecasting, temperature prediction. I am trying to estimate the temperature. The temperature value may be any value, right? It may be a 27 degree, it may be a 28 degree, it may be a 28.5 degree, it may be a 30.5 degree, it may be a 35 degree. Any value, right? So that is a continuous number. So that is also example for the regression problem. That is also example for the regression problem. If you want to forecast the wind speed, example for the regression problem. If you want to estimate the sales of ice creams in a day, you want to estimate the sales of an ice cream in a day based on the whether the day is a working day or not, what will be the temperature, what will be the humidity, whether there is a functions are nearby that location or not. So based on the multiple features will decide the ice cream sales. I think you agree, right? Suppose, for example, let's assume I have an ice cream parlor. In front of the ice cream parlor, there is one university, and beside my ice cream parlor, there is a function hall, and beside my ice cream parlor, there is a school. Let's assume. Okay, so the sales of ice cream is depending upon the whether the university schools are working or not. in a function hall, there is any function going on or not, and so depending upon the weather conditions, because generally no one will prefer to take the ice cream during the winter season. So that season, the temperature, that humidity also have an impact on your ice cream sales prediction, right? So number of ice cream sales, number of units of ice creams will be sold out in a day. It may be any, we don't know. It may be a 0, it may be a 10, it may be 100, it may be 50, it may be 20, it may be 30, any value. So that is also an example for the regression problem. So I think you are able to clear with how you can identify whether the given problem is a regression problem or not, right? So there is a regression problem or not, that is depending upon the nature, the character of your output variable, whether it is a continuous number or not, that will decide. Okay, you can see the statement, regression problems used to predict a continuous dependent variable based on the single. This is not a single, it may be multiple. Number of multiple variables may be any. Here I consider the 3 variables. Any number of multiple, not a single, it is a multiple independent variables, and you are going to predict one dependent variable, and this dependent variable by nature your dependent variable is a continuous number, then it comes under the regression problem. Hope you understand, right? Good. So if you understand the regression problem nature, now we are trying to move to the another type of problem, that is called as the classification problem. Classification problem. So in the classification problem, the output variable or dependent variable is not a continuous number. It is not a continuous number. That's what the difference from the regression problem to the classification problem. In a regression problem, the output variable, dependent variable, or the variable which you are going to predict, that will be a continuous. But whereas in case of the classification problem, your output variable is not a continuous number, it is a discrete value, a specific values exist, right? Now, again, the classification problems are classified into 2 categories. One is called as the binary classification, and another is called as the categorical classification problem. Binary classification and categorical classification problem. So what is the difference between the binary classification and the categorical classification? That we will discuss. So you can see by seeing this diagram, you are able to understand. I have an email information. I have an email content. So based on the content available within the email, I want to classify whether that email is a spam or it is a good. That means good means it going to the inbox or it going to the spam folder. So which type of email it is a spam or it is a good? It is a spam or not, whether it is a good or not. Only 2 classes. So that type of problem is called as the binary classification. Your output is only two output values, either 0 or 1. Your output value will be only 2 values. Your dependent variable has only 2 values. Your predicted variable has only 2 values. Your output variable, what you are going to predict, it has only 2 values, 0 or 1, yes or no. So that type of problems are the example for the binary classification. So I'm trying to tell. 1 minute, please. Okay, here only. So I previously told that I have an email. So based on the content in the email, I want to separate when my email is a spam or not a spam. So spam or not a spam. So it may be 0 or 1. Only 2 values, either 0 or 1, spam or not a spam. Okay, so your output variable will be either 0 or 1. The variable which you are going to predict has only 2 values, either 0 or 1, right? So that type of problems are the example for the binary classification problem. So previously we discussed one problem, right? So based on the features like fever, oxygen level, cough, cold, pulse rate. So I want to tell whether the patient has a COVID positive or negative. So this is also an example for the binary classification. Why? Your output variable has the only two, whether the person has a no COVID or the person has a COVID positive, 0 or 1. Only two values are available for your output variable. If you are working on a breast cancer diagnosis, if you are working on a tumor diagnosis, if you are working on some glaucoma disease diagnosis, whatever it may be, most of the healthcare disease applications, disease diagnosis applications, all are the binary classification problems only. Whether the person has a glaucoma or not, whether the person has a cancer or not, whether the person has a brain tumor or not, whether the person has a COVID or not, whether the person has a typhoid or not. So most of the healthcare applications are comes under the binary classification problems. In the binary classification problem, the output variable, that variable which are going to predict, the variable which are going to diagnose has the only two values. One is called as either only two values, 1 or 0, positive or negative. Right? Whether it is spam or not, positive or negative, whether the COVID positive or COVID negative. So only two options are there. So two values are exist for an output variable. Then that type of problems are example for the binary classification. Okay. Hope you understand. That is the example for the binary classification. Right now. Next part is a categorical classification. So in the categorical classification, the output variable or the variable which you are going to forecast or the dependent variable has discrete values only, like binary classification, unlike regression problem. In the binary classification, you have the discrete values 0 and 1. So like that, in categorical classification also, your output variable has the discrete values, like 0 or 1, like that, not a continuous value. But you have the more number of discrete values. You have the more number of classes. In the binary classification, you have the yes or no, true or false, 0 or 1, only two classes. But whereas in case of the categorical classification, you have the multiple discrete values. You have the multiple discrete values. So I will tell here, you can see this example. So multiple classification or categorical classification, it's called as a multiple classification, or it is called as a multi-label classification, or so there is a categorical classification, that type of things. Here you can see you have the different values. So it may be a dog, it may be a cat, it may be a horse, it may be a mouse. So different values you have. But here only two classes. Here we have the only two classes. You have the multiple classes, more number of classes. Either it may be a dog, it may be a cat, it may be a horse, it may be a mouse. So such type of things comes under the multi-class classification. So I want to give one more example. In 2019, I worked on a project called a mobile application for currency recognition to help the visually impaired people. Maybe you have a doubt. If he is a visually impaired people, how you can see the data available on the front end of my application to recognize the currency note? It will give the audio output also, so that visually impaired people also can work on it. Okay, fine. So I will give some brief idea about the project. So I want to build some mobile application. So if I keep Indian currency note in front of the camera, then the mobile application will give the voice output as it is a 10 rupee or 20 rupee or a 50 rupee, like that it will give the voice output. So this is an example for categorical classification or multi-class classification, because we have the multiple classes. What are the multiple classes? It may be a 10 rupee class, it may be a 20 rupee class, it may be a 50 rupee class, it may be a 100 rupee class, it may be a 200 rupee class, it may be a 500 rupee class. At that time 2000 also, there may be a 2000 rupee class. There are 7 classes are there. Multiple class classification or categorical classification. So that is an example for the multiple classification or categorical classification problem. I think you are able to distinguish classification problem and the regression problem. I think you are able to distinguish binary classification and categorical classification. If you try to compare the regression and the classification, in a regression case, your output variable is a continuous number. Whereas in case of the classification, your output variable is not continuous, it is a discrete value. Coming to the classification, again you have the two parts. One is called as the binary classification and another is called as the categorical classification. So binary classification means it output variable has only two possibilities, either yes or no, true or false, positive or negative, 0 or 1. Only two values will be there. Only two classes will be there. So that is the example for the binary classification. Whereas in case of the categorical classification or multi-class classification, so what it will be? So multi-class classification or categorical classification means your output variable is a discrete value, but more than two discrete values. More than two discrete values. More than two discrete values. So that is that means more than two classes. You can analyze like that also. You have the more than two classes, then it is a categorical classification or multi-class classification. So that is the one type of example for the one type of problem, classification problem. I will give one more example. Currently in my center, 4 students are working who are coming from Coimbatore, one institution from the Coimbatore. They are working as an intern in a Center for A&D Planning in SR University. Out of 4 students, 2 students are working on glaucoma disease prediction. So glaucoma disease prediction means they are developing some custom CNN model, and also they are using some existing convolutional neural network model, CNN models. Their main intention is they want to build one application. If you feed the retina image, eye image to that application, then that application will tell whether the person has a glaucoma disease or not. Glaucoma disease or not. So this is an example for the binary classification. We have only two possibilities, either 0 or 1. Whether it has a glaucoma or no glaucoma. So that is the example for the binary classification. And another set of 2 people are working on some other application. Their motto is they want to identify whether that eye is a healthy eye or that eye contains any diseases. They consider 3 to 4 diseases. So whether this is a disease correspond to class 1, disease correspond to class 2, or disease correspond to class 3, or disease corresponding to the class 4, which type of disease that patient has based on the image of the retina or eye. So that problem comes under the categorical classification problem, because we have the multiple classes, whether it is the healthy eye or class 1 disease or class 2 disease or class 3 disease or class 4 disease. It is a discrete values, but more number of classes. That's why it is an example for the multi-class classification or categorical classification problem. So I think you are able to understand the difference between classification problem, so regression problem, and the classification problems. Now we will move to the another type of problem that is called the clustering problem. Another type of problem that is called the clustering problem. Okay. So clustering problem means, see, in case of the regression problem, we are able to identify whether the problem is a regression problem or not. Regression problem or not based on which variable? Output variable, right? Similarly, in the binary classification also, that means if the output variable is a continuous number, then it is called as a regression problem. Similarly, in the binary classification also, if your output variable is a discrete, then it is a classification problem, and your output variable has a possibility of the only 2 numbers, either 0 or 1, only 2 classes, then it is called as the binary classification. And coming to the categorical classification, the output variable value is a discrete value, and output variable comes with multiple classes, the 10 rupee or 20 rupee or 50 rupee, multiple classes. Then it is example for the categorical classification or multi-class classification. In case of the regression problem, in case of the classification problem, we are able to identify based on the output variable nature. Based on the output variable nature. But in case of the clustering problem, there is no output variable exist. No output variable exists in case of the clustering problems. So clustering problems. Clustering helps to split the data into the several subsets. If you have a data, your clustering, if you want to split the data into several subsets, several clusters, then the type of problems are called as the clustering problem. Each of these subsets contains data similar to each other, and these subsets are called as the clusters. So in case of the clustering problem, there is no discussion about the output variable, because in case of the clustering problem, no output variables are mentioned or available. Not available. No output variable is available. No output variable is mentioned in the clustering problem. Okay. Whereas in case of the regression problem, in case of the classification problem, the nature of the problem you identified based on the output variable only. But whereas in case of the clustering problem, whether it is the clustering problem or not is depending upon your, in the clustering problem, there is no output variables. There is no output variables in the clustering problem. Only you have the input data or the input features. In a clustering problem, you have the only input features only exist. There is no output variable or target variable will be exist. Will not exist. Okay. No output variable, no target variable exists in case of the clustering problem. In clustering problem, only input features are available. In clustering problem, only input features are available. Is it clear, right? Now, so what the clustering problems are? Actually, the clustering problems are if you have the huge amount of data, you want to split the data into the multiple subsets, into the multiple clusters. If you want to split the data into the multiple subsets or the multiple clusters, then it's called the clustering problem. So how the models will divide the data into the multiple clusters or the multiple subsets? That is based on the similarities between the data points. That is depending upon the similarities between the data points. I want to tell one example, one case study for the clustering problem, general case study. If you observe, suppose let's assume we are newly joined in a institution for a BTech program, let's assume. On first day, on first class, on first minute, first hour, in a classroom, everyone will be like a one cluster. If your classroom contains 60 students, everyone looks like an independent, everyone like an independent cluster. Assume all the 60 persons, they don't know each other. Assume that they don't know each other, so that in the classroom, all the 60 people are separated. Maybe after 1 hour class, maybe after 1 day, after few days, we also come across, we also observe. After few days, all the 60 students are divided into multiple groups, multiple clusters. No faculty will tell you 4 people sit together, you 4 people sit together. No, but they will divide themselves into a group of clusters, into the groups. How they will divide into the groups? Randomly? No, based on their similar interests. Maybe after 1 week, they come to know each other about the other students also. Maybe some people are coming from the same area, they may be a cluster. Some people are coming from the same college, that may be a cluster. Now some people are passionate about the movies, there may be a clusters. So based on their similarities, based on their interests, they are divided into the multiple groups, they are divided into the multiple clusters. Same thing in the clustering problems also, you have the huge amount of data. And this data we are splitting into the multiple clusters, multiple groups based on the similarities. So that is the example for the clustering problem. Clustering problem. Okay. And I want to tell one thing, and one more thing I want to tell. one more small example I want to give based on the clustering problem. See, let's assume I am a operator in a substation. I am an operator in a substation. Okay. My duty is from midnight, that means 12 a.m. to 11 p.m. That means 11 p.m. means 23. Is a 0 means it is a 24. Sorry, 0 to 23. 24 means again it is a 0 again starts. So that means every hour we have the 24 hours, right? We have the 24 hours. For every hour, 1, 2, 3, every hour, my duty is I need to note down the load data on a substation. Every hour I have to see the transformer readings and note down the what will be the load at the midnight 12 o'clock, what will be the load at the 1 o'clock, what will be the load at the 2 o'clock, what will be the load at the 3 o'clock. Like that I have to note it down the data. Okay. So again I have to note down the date also. Let's assume I have to note down the date also. I have to note down the date also. For every day I have to note it down the all these hourly data samples. Okay, fine. Let's assume I forgot to mention the dates column. I forgot to mention the dates column. Only this data values are entered. Load data only entered. Let's assume I forgot this data date column, and I entered only data, load data, hourly load data information only entered. Let's assume. Okay. Now, after a few years, my manager came to my place and he said that he asked me, what will be the load pattern on our substation during the weekend and during the weekday? He asked me a question, that is, Mr. Venkatramana, what are the load patterns on our substation during the weekend and during the weekday? Weekday, how will be the load pattern? So can you visualize those load patterns? How it will be? Like that he asked. I am unable to give the answer to him. Why? Because I didn't mention the date. I forgot to mention the date. If I mention the date, then so what will be the date on Sunday? So according to Sunday, I can visualize the data. But I don't know dates also. I don't know whether the samples are related to the samples and the weekday samples. I don't know. Then how I can do? How I can solve this problem? How I can give the answer to my supervisor? Then in such scenario, what we can do? Because in these samples, you have the both weekend data and also weekday data. Every day, we note down the 24 hours load samples. So for every day, weekend and weekday, we have the 24 hours load samples. Now what I have to do? We have to split the load samples, 24 hours load samples into the two clusters, two groups. When you split the two clusters into two groups, then all the weekend load patterns will become weekday load pattern and weekend load patterns will be separated, clustered or separated. So that I will take one pattern from here and take one pattern from here, then I will draw the graph and I will show it to him. So what I am doing is total patterns what I have, lakhs of patterns I have, I am dividing into two clusters. When it is dividing into two clusters, so weekday patterns are coming similar patterns. All weekdays have the similar patterns. Weekends are the similar patterns. So based on similarity, they are divided into two clusters. Then I took the one sample from the weekend and one sample from the weekday. Then I can visualize it and I can show it to my supervisor. So this is an example for the clustering. Here there is no output variable. Only thing is whatever the lakhs of data I have, I am splitting the whole data into the two clusters, into the two groups. How we can split into the two clusters, how we split into the two groups, that is based on the similarities between the samples. What are the similarities from the this sample to this sample, this sample to this sample, this sample to this sample? Based on the similarities between the multiple samples, we are separating into the multiple clusters. How we measure the similarity? How we measure the similarity? So there is one parameter called Euclidean distance. that we will discuss when we discuss about the k-means clustering algorithm. When we're discussing about the k-means clustering algorithm, then we can discuss about the equivalent distance. So based on the equivalent distance, the samples or the data samples are divided into the multiple clusters or multiple subsets. So similar samples are comes under the similar clusters or the similar groups. Okay. So this is about the clustering problem. So I think you are able to understand the difference between the classification problem. You are able to understand the difference between the clustering problem. You are able to understand the difference between the what's called regression problem. So I think you are clear up to here. You are clear with the types of the problems, types of the real-time problems that can be attempted, that can be solved by using the machine learning. Okay. So next topic is I will discuss about the types of algorithms, learning algorithms. We will, after discussing this part, we will stop the first session for day one. We will take a break of 15 minutes, and later we will continue the second session for day one. Okay. So there are the three types of learning algorithms. One is called as a supervised learning, unsupervised learning, and the reinforcement learning. Okay. So what is the supervised learning? So we will discuss supervised learning. So only thing is when we apply supervised learning algorithms, if you want to apply the supervised learning algorithms, see your data. In supervised learning algorithm, both input features and the target labels are required. If you want to apply supervised learning algorithms in your data, you must have the both input features and the output variable. So if your data contains both input features and the output variable, then you will go with the supervised learning algorithms. It's like we know generally what we are following, that is called as supervised learning. See, if I am doing, let's assume I am the machine learning model. Let's assume I am some PhD pursuing candidate, research scholar. I am doing some work. I will show it to my supervisor, and my supervisor observe my work, and he will give some modifications. He will give some update. He will give some corrections. So based on the corrections, I will update my work, and again I will show to my supervisor, and he will see that document, and he may, if there is any corrections, he will suggest some more corrections, and I will do some that corrections. Again going back to my supervisor, and he will check again whether everything is fine. Then that will be closed. So here what we are observing here, there is just one person who always monitoring my work, whether I am properly doing or not, whether my work is correct work or not. So there is a supervisor available, faculty is available. That is called as supervised learning. Some person will be supervise our work. Some person will supervise our learning strategy. Some supervisor will supervise our knowledge, our updations. That is called as a supervised learning. So here also, so if you have difficulty to all these things what I am saying, simple thing is in your data, if you have the both input features and the output features, then you can go for the supervised learning. So simple example I am telling once again. Supervised learning, let's assume I have the machine learning model, and I want to train this machine learning model to diagnose the COVID based on the input features like fever, O2, cold, cough, okay, and pulse rate. Then fine. So I have the data. I have the different patients data, fever, O2, cold, cough, pulse rate, and prediction report, positive or negative. So for patient 1, example, patient 1, fever is 103, O2 is 86, cold S, cough S, pulse rate is very less, Okay. Okay. Then we collect the data, that is the positive. And I have another person. Fever is 98.5. O2 is 100. No cold, no cough. Pulse rate also very good, around 100. Then it is a negative. So like that, for third patient, fourth patient, fifth patient, sixth patient, I am collecting the various numbers of data. Now, based on this data, I want to make this machine learning model to learn. Then what we will do, I will give the first patient data to my model. I will give first patient data to my model. That means fever 103 and O2 86 and cough S and cough cold S and pulse rate is 60. And inside the machine learning model, I have some mathematical equations that we will discuss later. Some mathematics. See, machine learning model is nothing but a mathematics. So in the back end, you have some mathematical approach will be there. So based on that mathematical approach, it predicted as a COVID negative. Now the outcome, the result of my model is compared with my supervisor. This is my supervisor, that's the target variable. I compared with my supervisor, compared with my target variable, compared with your output variable. It is showing is a positive, but here it is a negative. So there is a difference between these two values, right? So based on the difference, you are going to update your model parameter. Who will update the model parameter? So based on your supervisor information. No, a machine learning model, you are predicting as a negative, but actually it is a positive. So accordingly, you have to update your model parameters based by using your optimization algorithm. Then model parameters will be updated. Now for the same data, after updating the model parameter and it will predict as a positive, then it is also compared with your master supervisor. Now the supervisor is saying that positive, yeah, here also positive, that's good, that's fine. You can, no need to update your model parameter for my sample. Now give the second sample to your machine learning model. So this process will be repeated. And whatever the outcome, that will be compared with my second target column, target variable, second value in the target column. So this is your target column or output variable can be act as your supervisor. So you in supervisor algorithm, supervisor is available, target variable is available, output variable is available. Okay, based on this output variable values, your model parameter will be updated for a given input features. So for a supervisor learning, you must give both input features. Also you have to give your target variables also. That's what my intention in the supervisor learning case. So here I am saying that in supervisor learning, both input features and the target labels are required. You have to give the both input features and the target variables. Both are required. That is supervisor learning. Okay. Now, I think you are clear. So in your data, in your problem, you have the both input features and the output variable. That is supervisor learning algorithm. Now unsupervised learning algorithm. So unsupervised algorithm is, I think we discussed already. So see, at end of the every session, every day you have some physics examinations also. So we will give some case studies. You have to tell which type of problem it is like that. Okay, fine. In case of the unsupervised learning, you require only input features. There is unsupervised learning, you require only input features. There is no output variable. There is no target column. Unsupervised learning. That means if you give the data samples like this, then if you give this data samples to your machine learning model or machine learning algorithm, then it will be your unsupervised learning algorithms will be split your data into the multiple groups or multiple subsets of the based on the similarity. So these all are in the one group because all are the square boxes. These all are in the one group because all are the triangular shapes. These all are in the one cluster because all are in the circle shape. So based on similarities, the data samples will be clustered into the multiple groups. In this case, there is no input feature. Unsupervised learning, there is no input features. Hope you understand, right? So in case of the unsupervised learning, there is only input features. There is only input features, no target variables or target features. No target variables are the no target features in case of the unsupervised learning. Okay. Now coming to the reinforcement learning. So reinforcement learning is subfield of machine learning. It is a huge topic, a separate topic. So reinforcement learning is a separate huge topic. It is a subpart of your machine learning that teaches agent or a model that teaches agent or a machine learning model that teaches agent or a machine learning model how to choose action from its action space in an environment, whether to which action you have to consider, whether your agent, your robot will move in the left direction, whether your robot will move in the right direction, whether your robot moves in the forward direction. The decision making can be done based on the rewards and the penalty. Based on the rewards and the penalty, that action will be taken. Okay, so your agent will take an action such that this will maximize its rewards. It will maximize its rewards. Okay, so that is about the reinforcement learning. In the reinforcement learning, your agent, your model will learn, will observe, will learn in an environment based on the reward and penalty basis. So it will learn in such a way that the agent will receive the maximum reward and less penalty. So based on that one, your agent will learn in the environment. That is in case of the reinforcement learning. But we are not much focusing on this reinforcement learning. It is a huge topic. We are trying to focus much in a separate workshop or FDP program in the future. So reinforcement learning. So these all are the different types of these all are the different type of machine learning algorithms. So supervised learning algorithm, unsupervised learning algorithm, and reinforcement learning algorithm. In case of this supervised learning algorithm, you must give the both input features and also target variables. But whereas in case of the unsupervised learning, only input features we are providing, no target variables or the target features or the output features. So these are things we have to remember. And the next topic is machine learning models, different type of machine learning models. So we will discuss about the different type of the machine learning models after the break. Okay. So now it is 3:20. So now it is a 3:20. So take a break for 15 minutes and please join by 3:35. So post session we will discuss about the different, not mathematical institution, what are the different machine learning models are available and what is the structure of the machine learning project, and we will discuss about the optimization. We will discuss about the optimization in the next 1.5 hours up to 4:45. Okay, so now you can take a break for the 30 up to 35. You can take a break.